Welcome students to lesson 20 of the natural hazards topic. In this lesson and the following lessons, we will be exploring one of the biggest issues of our time, climate change. To introduce it today, I will simply tell you what climate change is and how we know it's happening. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory and then mark your answers. Game time. So 1. Somerset levels. They're an example of extreme weather. 2. 600 homes, 14,000 hectares. 3. Social effects. 4. Destructive. 5. Low air pressure. 6. Eye wall. 7. The Purrock system. 8. The climate. 9. 24 hours. 10. Heat. Give yourselves a mark out of 12 because numbers 1 and 2 are worth 2 marks. If you got 10 or more, fantastic, you've really understood these ideas and remembered them. If not, complete this 1 to 10 over the next week until you get them all correct. To introduce the idea of climate change, I'm just going to show you some photos and some questions will appear. Use the photos and your own knowledge to answer the questions. So these two pictures show a glacier, which is a river of ice that's formed from snow being compacted over time and turning into ice in a valley like this. This picture is the glacier in 1941 and this picture is the glacier here in 2004. So number 1, you should have said the glacier has clearly retreated or gotten smaller. So you see the glacier comes all the way down the mountain here, but it's retreated and it's just left with water here and the glacier is only there now. 2, what do you think it's made from? The glacier is made from ice. Ice formed by many thousands of layers of snow compacting and being pressed together into ice over time. 3, why do you think this might have happened? Well, the big idea is global heating or global warming. As temperatures rise around the world, ice melts. And as you can see, that ice is retreating up the mountainside to higher altitude because it's warmest first at the lowest altitudes and then it gets colder the higher up you go. 4, how might humans be responsible for this? Well, if you knew about this already, you may have said that humans are releasing greenhouse gases, which are causing the atmosphere of the world to get warmer, and that is responsible for these processes that you see in this photo. So, over the next series of lessons, which will complete our study of natural hazards, we're going to explore 3 important ideas within climate change. The first one is what climate change is and why it happens. The second one is what problems does it create? And the third one is what can we do about it? How can we stop it or survive it? Let's go. So write the keyword please in the definition. Remember that climate is the average over a long time and it's about these 2 things. So a little test for you. Just write weather or climate next to 1 to 6. So number 1, you should have said climate because it's usually the wettest. That's the average condition in Liverpool. 2, climate. 3, weather. It's a one-off event. One-off events like storms are an example of weather. 4, climate, every year. 5, weather, one-off event. 6, sunny in winter, climate. Give yourselves a mark out of 6. Hopefully you got 6 out of 6. Fantastic. So, what is climate change? And how do we know it's happening? Those are the big burning questions of today. Excuse the pun. So please write this question and underline it with a ruler. Well, I'm going to show you 2 maps of the world that will help you understand climate change and what it actually means. Here's the first map. This map shows temperature change around the world. The lightest yellow means the smallest change, and the darkest red means the highest change, the largest change in temperature. And all the changes that we're talking about are warming. So this area here, for example, is warming very little, and these areas here are warming the most. Two big ideas you need to know about this. The first one is this. The temperature on Earth is not warming at the same speed everywhere. Near the equator, so around here, the temperature on Earth is warming the least typically. Whereas furthest from the equator, near the poles, the tundra and polar regions here and in Antarctica, in the south of the world, temperatures are rising the fastest. And the second big idea is that climate change, as we see it today, is showing a rise in temperatures around the world on average, but not the same speed everywhere. The second feature of climate change is this. It's not just temperatures that are changing, it's also precipitation, meaning rainfall. The smallest changes, or even the decrease in precipitation, is shown by brown or yellow colours, whereas an increase in precipitation, now and into the future, is shown by blue colours. As you can see, much like with temperature change, precipitation patterns are not changing the same everywhere. Some places around the world are getting drier. The main places around the world that are getting drier are on land, and specifically the semi-arid regions of the world, for example the savanna, such as the Sahel here, which is near the Sahara Desert, Australia, Southern Africa, Brazil, Europe, and central USA. These areas are projected to, which means in the future, get significantly drier, which means less rainfall, than they are now. By contrast, most of the areas around the world where there'll be increased rainfall are towards the poles, so for example north of Canada, north of Russia, and over the oceans, here and here and here. So, to understand climate change, you need to think of it as the change in the patterns of two key features of the weather, the temperature and the precipitation. So how do we know that climate change has happened in the past? You may have heard this before, that climate change has always happened. It's nothing new, and that's correct. And we know about this because we have some techniques for finding out what the climate was like many, many thousands, even millions of years ago. Let's go. Please write this subtitle and underline it with a ruler. The first technique that we have for understanding what the climate was like in the past is by looking at trees, and specifically tree rings. Every year trees grow by one ring. Some trees grow by more than that, other trees by less than that. But trees typically on average grow a ring a year. And one thing that we know about trees is that the older they get, the more rings they have. So, tree rings give us an indication of past climate, but how do they do that? We'll take a look at this ring versus this ring. You'll see that this one on the left is much wider than this one on the right. Trees grow when they have the right climate to grow. They need water and they need carbon dioxide in the atmosphere. When levels of carbon dioxide, a greenhouse gas, in the atmosphere are higher, trees grow faster and so they end up with wider rings, indicating a warmer climate. When levels of carbon dioxide in the atmosphere are lower, trees grow slower, like this, leading to a narrower ring, indicating a cooler climate. And so using tree rings, we can get a record of past climates up to about 2,000 years ago, because we look at the width of the tree rings to show the amount of greenhouse gases in the atmosphere and therefore the warmth of the climate. But what if we want to go back further? Well, then we can do this. Flowers have pollen in them. Pollen is how flowers spread the seed of plants and grow elsewhere. Bees, for example, help spread pollen. Now, often the pollen blown by wind lands on the ground, and when sediment and soil build up over the pollen, it gets buried underneath the ground over many hundreds of years. And so you end up with something like this. This is a soil core taken from the ground, the oldest soil, the youngest soil here. And buried within the soil are little tiny pieces of pollen. And by working out the type of tree that the pollen comes from, scientists can work out what the climate was like, because different trees require different climates to grow. So for example, if the trees here and the pollen they produced here are from trees that require warm, humid climates with lots of rainfall and high temperatures, then that would indicate that here, at this time in the past, the climate was much warmer. However, if the pollen that you find here, much more recently, is from trees that require cooler, drier climates, then you know that the climate was different. First of all, scientists can measure the age of the soil using a very clever technique. And then, once they know the age of different depths of the soil, they work out the type of plants based on the pollen, and from that they can work out the climate different times. This technique, pollen sampling, can go back more than 100,000 years. But what if we want to go even further? Then we have to do this. Every year, scientists go to Greenland and Antarctica and dig long tubes of ice into the enormously deep ice caps, which are sheets of ice on top of Greenland and Antarctica. These ice caps can be several kilometers deep. And scientists dig up these tubes called ice cores, and they first of all work out the age of the ice. Ice builds up over time as it snows. The snow lands on the ice sheet in Antarctica, and as more snow lands on top of it, that snow gets compacted and pressed into ice. And so the oldest ice is the ice that's at the bottom of the ice sheet on Antarctica and in Greenland. And it can be up to 800,000 years old, but some remnants of ice have been found to be even 2.7 million years old. So scientists, by knowing the depth of the ice, can work out the age of it. And once they've taken an ice core sample like this, they cut it apart and they create these little sheets, these discs of ice that look like this. And what you'll notice is that within the ice are bubbles of different gases. And one in particular is very interesting to scientists, and that is carbon dioxide. When ice freezes, gases in the atmosphere become solidified within the ice, like this. And so, using this fact about ice, scientists can work out the warmth of the climate at different ages. Because, for example, if there's lots of CO2 solidified within the ice 100,000 years ago, then you know that the climate was warmer then. If there's much less CO2 solidified in the ice 50,000 years ago, then you know that the climate was much colder then. And so ice core samples provide a record of past climates by capturing and solidifying gases as the ice froze. But we can go further still into the past using these. These are fossil records, and they can take us many millions of years back into the past. And here's how they are useful. Scientists dig up fossils from around the world, and then, much like with ice and with pollen and with trees, they first work out the age of the samples, which can go back to more than 100 million years old. And they can also work out the kinds of plants that the fossils are recording here. And they can compare these plants to plants that still live now. And by doing so, they can work out the kinds of climates that you had at different times in the past. And so through using fossil records and identifying the type of plants that existed then, scientists are able to work out whether a climate was warmer or colder at different periods of time in the past. And these four techniques all give us evidence of past climate change up to millions of years ago, and that's how we know for sure that the climate on Earth has changed over time. But what about now? Climate change is happening now. It's in the news as often as any other subject. So how do we know that it's happening right now? And in the last few hundred years? Subtitle, underline it with a ruler please. Thermometers, which have existed for the last few hundred years, have been set up around the world and have consistently given a record of average temperatures around the world. And here's the pattern they show for the last 150 years or so. The temperature on Earth has consistently risen over the last 150 years, with few drops, but the overall pattern is a rise in temperature. In fact, in the last 140 years, global temperatures have risen by on average 1 degree Celsius. This is the fastest rise in temperature in recorded history. And so climate change now is happening faster than ever before. Not only that, the behavior of plants is changing as well, and we can use that to understand how the climate has changed. More than 150 years ago, scientists started to record the pattern of flowering and blossoming plants and when they would bloom in spring. And the blossoming of plants depends on the change of temperature that happens in spring. Usually, in England, for example, this happens throughout March, then April, then to May. But because of climate change in the last 150 years, trees are blossoming earlier in the year, indicating that the temperatures are rising on average earlier in the year, which provides us with another piece of evidence of climate change and global heating. Another really important piece of evidence is this. These pictures were taken by satellite, so from space. This is a glacier about 100 years ago, and this is a glacier today. And you can see that the ice is far more extensive, which means further spread down the mountainside here than it is today. It's melted much further up, higher up the mountains, meaning that even at higher altitudes, the temperatures are rising around the world. And that can be clearly shown by the melting of ice. And that melting of glacier ice is contributing to the final piece of evidence of recent climate change, which is this. Sea levels around the world are rising. In the last 100 years, sea levels have risen by more than 20 centimeters, and most of that sea level rise has happened in the last 50 years. And that sea level rise is due to two causes. Number one, the melting of ice on land, such as glaciers. That water then flows into the sea, causing sea levels to rise. But number two is this big idea. When water gets warmer, it expands. It gets bigger. You can tell this happens because a thermometer works because the liquid inside the thermometer expands when it gets warmer, and that's why the liquid rises up the thermometer, because it's taking up more space. The same thing happens to the sea. This is called thermal expansion. And so a combination of thermal expansion and water being added to the sea from melting glaciers and the ice caps in Antarctica is leading to sea level rise. And so through all this evidence of past and recent climate change, we know that climate change has happened in the past, but we also know that it's happening faster now than ever before. Okay, time to assess learning. Write 1 to 12 in your books. Use the words at the bottom and put them in the correct gaps, and then mark your answers. Go for it. So 1, average. 2, temperature. 3, global. 4, do not. 5, evidence. 6, ice core. 7, 2.7. 8, fossil records. 9, animals. 10, temperature. 11, 1.1 degrees. 12, sea levels. Give yourselves a mark out of 12. If you got 11 or more, fantastic, you've really understood this. If not, or you got below 10, go back to the explanation and watch it again, and add any notes that you've missed. Now it's the practice moment, the most important part of the lesson. Make sure you complete this in writing in your books and then mark your answers in green pen. Go for it. Use this graph to answer the first 2 questions. So number 1, you should have said by about that much. 1 mark. 2. So to get this question correct, you need to say what's happened between here and here. So the temperatures have stayed roughly stable. And you could have given numbers. But you also needed to say how the temperature has increased since about 1940. 3. Make sure you explain each point like I have here. You need just one of these points, but you definitely need the second point. And 4, any 2 of these pieces of evidence that you see here. Remember, recent climate change, this question, not past climate change. Give yourselves a mark out of the total. If you lost only 1 mark or no marks, you've really mastered this topic. Okay. From this lesson, write 2 questions and answer them from memory. In a week's time, test yourselves on those questions to see if you still remember this. Next lesson, we're going to be exploring the causes of climate change, and I'm going to help you understand the key physics process that's happening that's making climate change occur, which is the greenhouse effect. Join me then.